Hello and welcome to Vodcast 4.1. Our first vodcast of Chapter 4 is focused on glaciers. By definition, a glacier is a thick mass of ice formed over hundreds or even thousands of years. In glacier formation, it's actually snow that kickstarts this process. And that snow accumulates, it gets compacted, and then it'll recrystallize to form glacial ice. If you think back to Chapter 2, the formation of sedimentary rock isn't really that different from the formation of glacial ice. Sedimentary rock forms when layers upon layers upon layers of sediment pile up on each other, and deep into that pile, there is extremely intense pressure. When years and years and years of snow accumulation pile on top of one another, the intense pressure exerted on the layers towards the bottom of that snow stack will contribute to glacial formation. Another important thing to realize about glaciers is that they move, but they move very, very slowly. Gravity is pulling on everything. We've said that before. And gravity also pulls on glaciers. So glaciers will flow very slowly in the downhill direction over time. Now, despite the fact that they flow slowly, don't underestimate their power. Glacial ice is an extremely powerful landscaper. And in future vodcasts, we'll look at some erosion and depositional features caused by glacial ice. A couple facts to note. The continent Antarctica is the world's largest ice sheet. And although Antarctica is the largest ice sheet in the world, Greenland is no slouch either. And now I have to state a sad fact. Due to climate change, it's very possible that all of the glaciers in Glacier National Park will have melted by the year 2030. Glacier National Park is a breathtaking park. I strongly suggest you visit it if you ever get the opportunity. And if you get the opportunity sooner than later, take advantage. Because if you wait too long, the glaciers may be gone. And then one picture I want to briefly mention illustrates the immense erosional power of glaciers. This enormous U-shaped mountain valley was actually carved out by glacial ice. Let's take a look at Glacial Budget. And Glacial Budget is an important consideration because it tells us if the glacier is advancing or if it's retreating. If it's advancing, you can think of the glacier as growing, and if it's retreating, you can think of the glacier as shrinking. Now in the first case, if accumulation is greater than wastage, the glacier will advance, meaning it will grow in size. In the second case, if accumulation and wastage are relatively balanced, the glacier's position will be stationary. In other words, it's not really advancing, nor is it retreating. In the final case, if accumulation is less than wastage, we will see glacial retreat. Due to climate change, we are seeing a lot more of the third case than we are the first case. There's one important point I'd like to make before going on to the next slide, and that's even if the glacier is retreating, the ice that constitutes the glacier is still flowing. I'd like to briefly discuss ice ages, because over the last couple million years, they have come and gone a number of times. The image shown in the middle of this slide depicts the Quaternary Ice Age. And as this image shows, ice spread as far south as the lower Midwest. So for us Illinois residents, we would have been buried under glacial ice. Now, if you're thinking that glacial ice was a thin little layer, you are horribly mistaken. That ice sheet could be a mile or more thick. So if you've ever been to Chicago and seen the towering skyline, that ice sheet would dwarf the tallest buildings in downtown Chicago. The two maps shown on the right side of the slide demonstrate the awesome landscaping power of glacial ice. This is what our region of North America looked like prior to the Ice Age. There were no Great Lakes. There were rivers in places that no longer have rivers. And it's really interesting to note that the Mississippi River's path was altered dramatically by the advancing ice sheet during the Quaternary Ice Age. In Image A, we see a more modern map of our region of planet Earth. It's kind of neat that the Great Lakes are composed predominantly of glacial melt. On this last slide, I want to overview the last glacial maximum. As shown in this graph, the last glacial maximum occurred about 18,000 years ago, and sea level would have been 100 meters lower than it currently is today. Take a look at this map that's centered on the United States. This map shows the present-day coastlines, but look at how much thicker Florida would have been just about 18,000 years ago. And look how shrunken the Gulf of Mexico was during the last glacial maximum. It's important that you realize that sea level is tied to glaciation. Sea level will drop as Earth approaches glacial maximum, and sea level will rise as Earth approaches glacial minimum. Due to climate change, we are on the fast track towards a glacial minimum. And due to that fact, we are seeing sea level rising at a relatively rapid rate. Okay, that concludes the first vodcast of Chapter 4. This vodcast served as a nice overview of glaciers. In the vodcasts that follow, we'll dig a little bit deeper into understanding glaciers, and we'll talk about erosional and depositional features produced by glaciers.